Okay, so previous video we talked about entry. The pathogen's got to get out also because it wants to find a new host, right? And a lot of times you want to get rid of it. So how does a pathogen get out? So lots of ways. Secretions. Right, so think of mucus and bodily fluids. Some pathogens actually induce secretion formation so that they can get out. So even though you're going to sneeze or you're going to blow that snot out, it potentially has pathogens in it. Excretions, right, is more like pushing things out of your body, so your urine, your feces. So we'll talk about the fecal-oral route. That's an excretion from the body. They can get out through the blood, primarily with insect bites or needles. Okay. This makes the pathogen pretty susceptible to you either sharing needles or getting bit by an insect. And so one of the things I want you to think about is, if you were a pathogen, how might you want to get out of the host? What would be some advantages, disadvantages? Major excretions like diarrhea, coughing, sneezing, vomiting, right? Especially diarrhea. There are lots of different bacteria that induce you to over-secrete water in your intestinal tract and make that pathogen come out. That's also, we'll talk about, part of the fecal-oral route. But coughing, sneezing, vomiting, these are other ways it can get out. And through sex, right? So there are sexually transmitted diseases that depend on a promiscuous host, right? So again, as you're thinking about exit and transmission, some forms you just don't have a lot of control of as a pathogen. Okay, so factors that are going to affect transmission. So transmission really means from host to host. Okay, so you want to get to a new host, so you have new cells to infect, so that you can make more of whatever you are, virus, protozoa, helminth, bacteria. So the success of this transmission is not just getting out, but getting to that next host. And some of the things that affect transmission is the number of microbes, I'm going to say shed, or the number of microbes that exit. Right? So if you're not going out in mass, you have a lower chance of finding another host. Stability in the environment. Okay. So if you are very susceptible to drying out in the environment, such as a bacterial cell or an enveloped virus, then you need to get to your next host quickly, or you need to stay moist. On the flip side, things like naked viruses, so they don't have the envelope, spores, cysts. We talked about some organisms make these. These are much more resistant to changes in the environment, harsh conditions, and so they have a greater stability in the environment, so they have a greater chance of being picked up by the next host. And efficacy or efficiency, I don't know if those are two different words. Anyways, I'm writing efficiency of infection. So the next two slides I'm going to show you is it's not always a one-to-one ratio of, you got touched by one Streptococcus pyogenes, now you've got strep throat. Depends on how efficient that microbe is to infecting the next host. So how many microbes does it take? So as we do studies in the lab, we find these infective doses. So look at Vibrio, the organism that causes cholera. You need to take in millions, there's not billions, of Vibrio to get a productive infection. Luckily for Vibrio, it comes out in the billions, so it has a good chance of infecting. Here's another one, C. diff. It takes about 7 spores before you get an infection. And this is really not a hard number, but just based on experiments in the lab where they say it's not a 1-to-1 ratio. We can't just give the mouse 1 C. diff spore and it gets C. diff. It takes about 7. So that's where this infectious dose comes. Polio, 3. Fungi, 10. Amoeba, 1. Right? So we talked about, well, this is a different amoeba. This is one that causes a gastrointestinal infection. But you can see this huge range of how many microbes it takes. Viruses are super interesting in that they have something called a particle to PFU ratio. Particle means number of viruses. So we count these under the microscope. PFU is plaque forming units, and that means it can make a productive infection. So in fact, viruses make lots of particles that aren't infectious, and the reason for that is that many viruses mutate. The advantage for a virus is, say it gets one good mutation, and that mutation gives it some advantage, and then that virus will go on to replicate more. But maybe it makes 10,000 that aren't. Excuse me while I pause, my daughter's interrupting me. I told you, the basement where your bag usually is, by the dryer. Go. I don't know how to do a good pause. I'll try to cut that out. All right. She's going on to ballet class and doesn't know where her shoes are. All right. So not all virus particles are infectious. It takes sometimes exposure to multiple microbes in order to get a productive infection. All right, transmission. So how does that virus get from host to host? And respiratory or airborne transmission. I don't know if it's that or if that's the name of that thing. But anyways, through the air is the number one most effective way for microbes to get from host to host, right? So from the lungs out the respiratory system. That's the classical sneeze, but even just talking. Your book talks about, I thought this was really interesting, the letters F, P, T, S. And as you say some of those letters, you will spit on yourself, right? And so our language promotes transmission of microbes, right? Because the way we talk and pronounce words, we're constantly putting out that aerosol. So coughing, sneezing, talking. Right? And that's why we all get sick at the beginning of the semester. Once we come around, everybody, at least kids are that way. They all bring colds home after a vacation. Nasty. Fecal oral route. Number 2. Are we having issues? fecal my goodness. Oral route. I can't even imagine what it's like for you guys to sit there and listen to this, but I'm doing the best I can. Yep, poop it out, eat it up. Okay. Number 2 way of pathogens getting transmitted, partly due to our poor hygiene habits, right? So you can get it on your hand, you can get little bugs transmitting it, it can get into the ground, it can get into the water, right? And that can contaminate your food, or especially contaminated drinking water, right? We all need water to live. So in developing countries where they don't have purification and water sewage systems, this is the huge method of transmission. You can't treat that sewage, and a lot of times they use their rivers that are right there as not only their washing grounds and their water sources, but also bathroom. Hand washing. Oops. Is the number 1 way that we can break this chain. So you see in every bathroom now, employees must wash their hands before returning to the restaurant, right? So there's so many diseases that can be transmitted through this fecal oral route. Hepatitis is one of them that we worry about with food workers, as well as some other pathogens. Okay. Transmission, venereal diseases. Venereal. Sexually transmitted diseases. Right? This is why HIV has been so successful. People like to have sex. And here are some different microbes that can be transmitted sexually. So you have mucosal discharge. You have mucosal sores. You have semen. Right. The challenge with this for a pathogen is you need to have a promiscuous host, or one that has sex often, or ideally one that has sex often with lots of partners, right? So you can get to lots of new hosts. But as some of these microbes have shown, doesn't seem to be a problem for many of them. There is some STDs that are transmitted through saliva, although that's a much lower incidence. You just don't get the buildup or the number of pathogens in the saliva. And really, our prevention, I guess I didn't talk about prevention. Well, I talked about hand washing and obviously covering your mouth for respiratory ones, is education. We have to let people know how sexually transmitted diseases are so that they can change behavior and attitude. Right? So for a while, people were sure that HIV was given from God to punish homosexuals. Well, we know that's not true, right? And so if we can educate people on, hey, you know what, you never have to become HIV positive if you take these precautionary, if you practice this safe kind of behavior, and we have to change attitudes to prevent this transmission. Okay, a couple more slides on transmission. So vertical transmission I was talking about is mother to child. And we talked about there are certain pathogens that can cross the placenta in pregnancy. Placenta. Okay. That's our TORCH acronym, which unfortunately the others is going to be a long list. During childbirth. And I think I mentioned when we were talking about normal flora that they're looking at the different flora between children born vaginally versus C-section. So a couple pathogens like herpes and group A strep are things that they will monitor or screen the mother for to make sure that it's not passed onto the child through labor. In developing countries, we can prevent some of this a lot better than less developed countries. And this is really affecting the child's eyes and respiratory. And in case you didn't know, there's a lot of blood involved in childbirth. So a lot of ways that the barriers have been broken. Breastfeeding through the milk can also transmit, especially viruses. So HIV, cytomegalovirus, human T lymphotropic virus, which is a retrovirus. I don't remember if I've seen anything about Zika, but Epstein-Barr virus can also be transmitted. What's interesting, again, in developed countries, we can deal with this. We can use formula. We can use things to supplement the nutrition. But in less developed countries, we do not discourage mothers from breastfeeding because without the nutrition, the child's going to die. Okay, you've got transmission through punctures in the skin, so bites, needles, transfusions. Okay. Not a lot we can do about the biting bugs right now. I'm trying to just take a look at, trying to remember what we're looking at versus my virology class. People are talking about ways to reduce the mosquito population to potentially reduce transmission through bites. We'll see what happens with that. But most of our blood supply, or I should say our blood supply, is clean, except when they find new things that can be transmitted by the blood that they haven't known to screen for, right? But needle to needle sharing, huge way that pathogens can be transmitted. Zoonosis. This means transmission from animal to humans. Okay. A few ways this can happen is through a food source. So for instance, they think that HIV came from monkeys to humans through bushmeat. Right? So you're hunting something and you're cutting it and it's exposing bodily fluids and blood, you could potentially get a pathogen from that animal. Undercooked meat. We've talked about this for some of the protozoa and helminths. Shellfish. People like to eat raw oysters. They can have pathogens, so you're ingesting that. We talked about prions are transmitted through our food. But sometimes from our pets. So rabies and toxoplasma. Reptiles can carry salmonella as part of their natural flora. Sometimes from wild animals, such as influenza. The ones we always worry about are the ones that are coming from the waterfowl or the swine reservoirs. So these guys can be infected by influenza and not be sick, but when that virus is able to jump to humans, it can cause a lot of problems because it looks so different that we don't have an immune response ready to tackle it. Fecal matter from any animal can have bacteria, and I heard that water dishes, if you have a bird water dish outside, huge source of bacteria. So make sure, one, you keep it clean because it can transmit these bacteria from bird to bird. So you don't want to make all your birds sick if some wild bird comes out. And you also don't want to make yourself sick. Okay, I'm going to stop there and I'll make one more video on spread in the body.